DevelopSec, Developing Security Awareness with James Jardine, brought to you by Jardine Software. Hi, and welcome to episode 25 of the DevelopSec podcast. I'm your host, James Jardine, and today I want to talk a little bit about static analysis and how we can use that in our development workflow to be able to analyze our code base or our binaries for security flaws. That's the whole purpose, really, for static analysis, is to be able to scan the source itself, as opposed to dynamic analysis, where with dynamic analysis, we're actually scanning the system as it's running. So if it's a web application, it's actually up and running. We're going to provide inputs to it. The system will actually provide the outputs, so we see processing happening real time to be able to look for certain types of security flaws. But before we get to the dynamic side, we have to think about the static side of things, because that's before we get there, right? Before we can actually run it and all of that, we're sitting there writing the code. And one of the cool things we can do with static analysis is actually build it into our CI, right? Our continuous integration. We can build it into our workflow or our business process. So that way we can, upon every check-in, if we wanted to, we could then analyze that code to make sure we haven't introduced new security vulnerabilities. Now, keep in mind that static analysis doesn't find every type of vulnerability, so you can't assume that what static analysis is going to do is be your one and only security solution in the development cycle. It's one of those key components to what we're doing for security within our development cycle, but in reality, it's just a small component, right? This is kind of our first level as far as scanning tools, to where we're going to dig those in and start analyzing those outputs. So static analysis works in a few different ways. One way it works is by actually just kind of looking through source code, looking for strings. That's how we find things like passwords, keys, encryption stuff stored, any other type of hard-coded values, if you will. Those are all found with doing really basically kind of keyword searches. The other way we do it is the tool actually loads all of the code base in, and while it doesn't run it, right, it's able to run stuff through and follow how inputs go throughout the system, right? How does the data flow? And it analyzes that flow to be able to try to detect security issues. Now, of course, depending on the tool you're using, depends on how good it is at finding things. Some have a higher false positive rate, some have a higher false negative rate. So we have to think about that as we're going through. But the goal here is that it can look and say, hey, I've got an input from the web here, and it's txt username, and I'm going to follow it through every function call as it goes through the system to wherever it's going, maybe the back end, and it's going to analyze and see, hey, if it's going out to a database connection and we're using things like a SQL connection object, are you doing inline SQL? Are you doing parameterized queries? How are you calling that? And of course, it recognizes certain things as being security flaws like inline SQL. Then it's going to take and look and say, hey, you pulled something from a database or the data source. We're going to trace that back down through to where it goes out to the client. Once it goes back to the client, it's looking to see, hey, did you do any output encoding on this data? Did you do anything to protect it where it's going down? And some scanners are a little bit better than others at being able to detect the context for cross-site scripting, or whether it's an attribute, whether it's HTML context, Java context, right? There's all kinds of different contexts we have to look for here, and not all scanners are equal. But that's what it's doing. It's watching that data flow through the system and looking to see if stuff's being sanitized, if you're properly handling things, if you're making calls that are unsafe calls or known insecure calls. That's what it's looking for. So we have to understand that static analyzers don't find everything, right? They have a difficult time finding authentication flaws, authorization issues. Some logic flaws are difficult for them to find. So we can't just rely solely on them, but it is a first good round. And I've seen a few companies that implement it very well, where it's actually integrated into the build process. So when I check code in every night, that process is going to kick off and the scanner is going to run against the source code. And then we can see if any new vulnerabilities were identified, and then we can remediate them right away, right? We know the next day, hey, something was checked in that has a vulnerability, let's fix it. So this helps reinforce with the development team what you're doing incorrectly from a security standpoint, so you can immediately fix it and learn from it, and hopefully next time we won't do it again. So there's a couple things we want to think about when we're looking to implement a static analyzer. The first thing, obviously, and I hate it to be the first thing, is budget, right? There are free tools out there. Some of the tools out there, like for .NET, they have cat.net. This thing hasn't been updated since like 2009. So while it may work a little bit for you, it was promised to be updated, it never got updated. So it may still work. I actually know development shops that still use it as their kind of initial cursory run. It is free, right? It's something we can embed into our solution. There's also things like Brakeman, which is a Ruby static code analyzer. And there's a free version of that you can set up. If hopefully you're better than me at setting up stuff for Ruby, because every time I install Ruby something or other, I'm missing gems. I've got the wrong RBM. I never have good luck with Ruby stuff, but I've actually used Brakeman, and it's a good first start, right? If you don't have any budget to get going, those type of tools, and there's other ones out there, are a good place to get going. But then you go from the free side up to the commercial side. Now things start getting a little hairy, right? You can get expensive really, really quick when you start looking at these. Maybe spending $60,000, $100,000 a year, for licenses for some of these tools to come in and analyze your stuff. Now, from what I've seen, most of the pay-for ones are better at what they're doing, but that doesn't mean that's always the case. But they often offer more features. Maybe they offer support to help you out. So that's something you have to consider. What is your budget when you're thinking about getting static analysis going into your system? The next thing we need to think about is, do we do managed services or do we do this in-house? Right? Because those are really our two big options. Managed services are kind of nice if you don't have resources locally to be able to implement stuff, tie it into your systems, analyze the results for false positives, that type of stuff. Well, then I can now take it to a third party, somebody like a Veracode, where you upload your binaries to them, they scan it, they have people that are trained to look at the results, try to weed out those false positives for you, and then give you the actual results that are worth looking at. So it saves you a lot of time. Right now, usually it's a couple day process from when you upload, right? But it's a very simple process, at least from when I did it a few years ago with Veracode. It's a fairly simple process. You upload your binaries, and 2-3 days later you get an alert, hey, it's done, your results are ready. And you can go up and look at them, and they have a whole portal that you can do a whole bunch of stuff with. That works for some people. Now, some people do have the concern of handing their code over to another third party, but there's a lot of people that are okay with that. They're okay passing their binary up to allow somebody to analyze that. Obviously, you're putting a lot of trust in these managed service providers, and we hope that they're actually, putting as much effort in towards securing their environments, right? Knowing the sensitivity that they're dealing with. And let me just add a disclaimer, because I did mention Veracode here, and I'm going to mention HP Fortify in a moment. I don't endorse any product myself. The reason I mentioned Veracode, HP, I might mention White Hat for their Sentinel service for dynamic scanning, which we'll talk about in another podcast. The reason I talk about those is because I have direct experience with them. So I like to be able to talk about the experiences I've had. That's not to say another tool like Acunetics as a in-house tool isn't a good tool. It's just to say, hey, this is what I've seen as I've used this type of service. But I encourage you that as you're going to look for this stuff, do the research, ask around, ask other people how they've worked out, how the tool works for them, what they do like, what they don't like, so you can start to see. Because you gotta remember, the one question you have is, What's my end goal with adding this in? Why do I want static analysis? And once you understand your goal of what you're trying to get out of it, that will also help you understand which product is going to be the best product for you. Maybe it's a free version. Maybe it's that free tool out there that works just as well. So you have the managed service, then you have in-house. Now, there's a lot of benefits to in-house, cost not usually being one of them, because the products that you buy to install locally tend to be on the higher price range. But there's lots of other benefits to them. So I mentioned HP Fortify, their source code analysis tool. I've used it extensively. I think it's a good tool. It finds a lot of stuff. Keep in mind that as these tools go out, some stuff they find really well. They may identify other stuff that needs a lot of inspection. But as you use the tool, the more you get used to it, the more you understand that, and the quicker you are at weeding out the stuff you know doesn't quite work so well for your system, and the stuff that does. So with the in-house, you're going to bring that in. You're going to manage that locally. You're going to install it on a system within your network. And the cool thing here is we can actually build this directly into our environment, right? Remember I talked about that nightly build, and it kicks off that scan, and then we see the results the next day. We can tweak it there. We can add that into our workflow and get that immediate feedback. We've also got the ability where some of them are extensible. So not only can I kick it off, I can also write rule sets. Fortify lets you write rule sets for it. So if you identify something that isn't quite working right, and I'll give you an example of this. We actually had a group that would code their own output encoding, and their output encoding worked well. It was a good output encoding routine. I don't often recommend writing your own, but it's possible. And this one here was a solid output encoding routine that was being used. But Fortify wasn't aware of it. It didn't know that routine. So it would always flag cross-site scripting. So we could go in and write our own rule set to say, hey, if it flows through this routine, then we're not cross-site scripting, right? And we can reduce some of those false positives and clean them up. Also, if you find something that just that tool doesn't notice, but you're using it, some function in a certain way that the tool thinks is wrong, but is actually right, it just doesn't know about it, so that's why it flags it as incorrect. Well, then now you can write rule sets to make that better and cut down on some of those false positives. So there's a lot of benefit to bringing that in-house. The downside, besides cost of bringing it in-house, is do you have the resources to be able to execute it in-house? It takes a little bit of time to get up to speed on how to use these type of tools, how to integrate them into your environment. So do you have the know-how internally and the time, if you don't have all the know-how, to learn it, and then, of course, the time to actually do all the implementation to get everything up and running, right? And so that's something we really want to think about as we think about managed versus in-house. Managed, I can sign up for an account, I can upload a thing, and I've got a response pretty quick. In-house, I got to set up the tool, I got to make sure it's working. There's a lot more steps, but the payoff there is that once you get it tuned into your environment, it actually works most likely a little bit better for your situation. But overall, static analysis, I think, is an important part of our development workflow to identify these type of bugs. Remember, QA can identify these as well. Static analysis is going to check it on check-in, but when we actually deploy out to QA, well, there's our second layer. QA is looking for this type of stuff as well, but hopefully there's going to be much less of it because we've caught it with that static analysis, right? And as we start throwing dynamic analysis into it and using automated tools to capture some of that, what I would consider low-hanging fruit, then we can spend more of our time manually looking for some of the more complex security vulnerabilities that exist out there that we need to resolve for our applications. So as I mentioned, if you're going to look at implementing static analysis, ask around, talk to people that use the tools, reach out to other people, see how they like them, see what works, look at what's going to work in your environment, right? Talk to your developers, talk to if you've got DevOps or whoever's going to be implementing this tool. If you think about doing it in-house, who's going to do this? You don't want to drop a whole bunch of money and then realize you got to spend a whole bunch more money to get the company to come in and actually set everything up, and now you realize you overblew your budget trying to get this thing going, and then it's just no good, right? So you want to think about that and ask around and be cautious, because static analysis can throw a lot of results back on the first time you run it, and it may take a while to weed through those results, but you can sit there and suppress those. And so as you keep running it against that same generic code base, right, that baseline code base, and add little tweaks here and there, you'll start to see less items popping up that are the false negatives, because you can go in and clear those out. But it can be a bit overwhelming when you get that first run and you have to go through and say, hey, oh, no, those are false positives, and clear all those out. So be prepared for that when you do it. Get demos done. Ask people how they work. But think about implementing these, because when you start doing static, you start doing dynamic. And remember, just doing it isn't going to solve anything. To say I have a static analyzer doesn't solve anything, right? We actually have to act upon the results and start fixing those, learning from those, becoming better at writing code that is less susceptible to these security flaws, and just having better applications overall, right? So we do the static, we do the dynamic, we have QA, we have pen tests, we have all these different layers, right? But a lot of this stuff we can build in local, and catch a lot of it before it gets out of our dev environment, before it gets out of our QA environment, and we can start having better applications. So I hope you enjoyed and got some information that helps you if you're thinking about static analysis. Going forward, again, we'll talk about dynamic analysis a little bit later on, because that's another interesting topic and another tool set entirely. So, it should be interesting, hopefully. Again, if you have any thoughts, feedback, send it back to @DevelopSec on Twitter, or you can reach me at my email address, which is james@jardinesoftware.com. I have a post for this actually on my jardinesoftware.net address, but I'm probably going to put that post as well on the DevelopSec site as well, so that way it's available in both places, and we'll get that dynamic one out there. So I hope you enjoyed listening, and I will talk to you next time. You have been listening to the DevelopSec podcast with James Jardine. Follow us on Twitter @DevelopSec, and visit our website at www.developsec.com for more episodes and information.